Oh, I like to live a little dangerously. All right, good morning. I got a little 1.4 video as we teach the actual class, so there might be a little bit of questions, so bear with us. We did a nice intro of what two columns proofs were. We saw a nice little video. We also looked at what UNO proofs can be as far as logic is concerned. Okay, so we've already done that. Today we're going to start doing two-column proofs because we have these, what we call theorems. What the heck is a theorem? Theorem is a mathematical statement that can be proven. We have other statements like postulates. I'll give you an example. What is a postulate? I don't know if you have this. You have this slide in your notes, but it's probably in another place. You have that slide? Yeah, I actually put this slide on this morning. What is a postulate? We've actually had this before. Remember when I asked you to hold up two fingers and I said how many lines go through that? What did you say? One. You said one line goes to those two fingers. Why? Because there's a postulate that says that only one line can go to two fingers, or actually it says 2 points determine a line. And that is an actual statement. That's an actual rule. Do we have to prove that? No, we just accept it to be true. It's called a mathematical fact. It's called a postulate. Okay? We also have definitions. Have we had any definitions yet? No. Yes, we have. Here's two examples. Do we know what a right angle is? Yes. What constitutes a right angle? If it is right, then it is 90 degrees. Could I reverse that? If it's 90 degrees and it's right? Yeah. So we have a definition for, did I have to prove that? No. No, we just accepted it, right? Here's another one. If two angles have the same measure, then they are congruent. That's the definition of congruency. We've done that before too, right? Now we do have some theorems. We haven't had any theorems yet, but we're going to have two today, and we're going to actually prove those theorems. And here's the cool thing. Once you prove the theorem, then you can use the theorem, because theorems are actually shortcuts, and you're going to see that later. So what's an example of a theorem? If two angles are right, then they are congruent. That makes perfect sense, doesn't it? What would be the logic behind that? If two angles are right, what does that mean to us? If they are right, then? If two angles are right, then each angle measures 90 degrees. And if each angle measures 90 degrees, same measure, then they are congruent. Because that's the definition of congruency. You see the logic? That's only a three-step proof. We're going to do it in a little bit. But that's the idea of proofs. And then, later on, next week, I give you, hey, angle A and B are right angles. What are you going to say?
They're congruent.
They're congruent. Why? Because of the theorem. You see how this works? And then we're going to build on that. We're going to get more theorems and more theorems, more definitions, more postulates. Then the web gets a little bit more intricate. But we catch better bugs. Thanks for laughing. You didn't really laugh. Why is that thing upside down? That's not good. Too late now. I'm going to let it roll.
It's not upside down.
The camera's on the other side. That won't matter, will it?
No.
All right, start from the beginning here. Feeling good? Yeah, I also like to write theorems in the what? At least at first. And the if-then. Why is that? Because you'll know that the if part is always what I'm giving you, right? And then the then part is what we are proving. Okay? You know, even definitions, right? If an angle is right, then it is 90 degrees. So I do like if-thens, but we'll talk more about conditional statements in sections 1, 7, 1, 8. I was doing a bit of a master plan this morning. We're going to do 1, 4 today. You're going to have the weekend to do it. And then we're going to do 1, 5 on Monday. But that's going to be a 2-dayer probably, Monday and Tuesday. And then on Wednesday, we're going to do 1, 7 and 1, 8. But that's going to go Wednesday, Thursday, and Friday. Then we'll start working on the practice test, review for chapter 1, and we'll probably be testing the following Tuesday, first tests. It's big for a lot of you guys because, you know, you've had a lot of little grades, haven't you? And the grades aren't really good right now. We can all admit that. They're not as good as they're going to be. But this first test can really bring you up. So make sure we do a good job from here on out. It's important. We good so far? Yeah. I'm pretty happy so far. Good intro. We kind of know what two-column proofs are. This is the procedure for doing a theorem. First of all, we present the theorem. If two angles are right, then they are congruent, which I've already presented to you. Then we're going to prove it. We haven't done that yet, but we're getting ready to. All theorems can be proven. Will we prove every single theorem that we use this year? Yeah. No. It even says it right here. Sometimes we just accept it. Well, we could, but I don't. I don't prove them all. And then you're giving chunk it. All right. So when we do these two-column proofs, like I showed you on the UNO, you had the rules, right? Your justification were just the rules. Our justifications in two-column proofs for right now will probably just be what? Definitions and maybe some givens and stuff. But as we progress in two-column proofs, our reasons, our justifications will be what? Definitions, postulates, which we've already talked about, properties. What the heck's a property, Eric? Somebody over here is paying attention. What's a property? Give me a property. Stop fingering your iPad, Londano. You're getting me nervous. What's a property? Algebraic. I'll give you algebraic property. Who remembers from algebra?
Commutative.
Good. That's a property. Give me another one. Reflexive property, right? Associative property. Just now I stimulated the mind. Yeah. Those are all properties. Could we use that in our proofs too? We will. And of course, theorems. We use theorems that we've proven to use to prove other theorems sometimes also. So we will use all these things in our two-column proofs. But today, remember, today is kind of an intro to two-column proofs, so they're not going to be that difficult. You should be fine with them. Now, for right now, I'm going to give you the given. I'm going to give you what we're trying to prove. I'm going to give you the diagram. All that is going to be given to you. As we progress later on, you could actually be given a theorem as a statement, and they could ask you to prove that. Would that be easy? No, that's a little bit more difficult. Now you got to create your own diagram. You got to create your own if, then, but that's not till another chapter or so down the road. So most of the time we're going to give you all that stuff, right? Then we have to plan. Did we plan that UNO proof? Yeah, we did it. We said, okay, we're going to play these cards, and then I wrote it down, and then I justified it. So planning is a big part. It's a big part in two-column proofs. This is also very important. The first statement is always going to be the given. Whatever I give you. If two angles are right. So what do you think I'm going to give you when I prove that?
Two right angles.
I'm going to give you two right angles. In the UNO, I said, there's a given card. That was your given. And then I asked it, I want you to prove that I can end with an 8. What are we going to prove on the right angle theorem? That they are congruent. So, exactly. So we're going to start off with what? What you're given, and you're always going to end with what you're trying to prove. There it is. You're going to present your argument, and the last statement would be what you're proving. We're going to use definitions, postulate that. Two-column proofs are not always proving theorems. Sit down. Two-column proofs are not always proving theorems. Are they going to be for theorems right now today? Yes.
Yeah.
But sometimes I don't want to prove a theorem. I just want to say, hey, I would love to prove those angles congruent, or that those segments are congruent, or that these equal 90 degrees. I would love to prove that. So there are other proofs, not just proving theorems. Here's our first one. Are you ready? That was kind of like, bah, right in your face, right? So what do we notice first of all? Here's a proof. If two angles are right, then they are congruent. So specifically, I've given you what? Okay, if two angles are right. Well, I've given you what? Angle A and B are right. So the if part is the given. Okay? And then what am I trying to prove? So, if I'm given A and B are right, then they are congruent. I'm going to start here, and I'm going to end here. Does the diagram help?
Yes.
Absolutely. There will always be a diagram. For right now, the diagram is going to be given, so it's pretty easy to tell. The diagram better have a what? A better be a right angle, and B. So, something I'm going to add to this diagram, I think what they should have done, if not, I'm going to do it. What can we do? Now I know, now I'm not assuming that A and B are right. Okay? Sorry. So what goes in the first statement always? Given. Whatever is here is going to go where? Into the first statement. But what's my reason always? Given. That's how I'm going to start. Now, I already asked you, how am I going to get from here? How can I prove that right angles are congruent? Let's kind of work backwards. Let's plan. If A and B are congruent, the only way to prove congruency is to prove that they have the same
Angle.
The same measure. So, if they are right, then I can say what?
They're 90 degrees.
If A is right and B is right, then A equals 90 and B equals 90. That's pretty logical, isn't it? Here's the hard part. Let's go Luca in the back. Luca V. Mr. 33. 33 in the quiz. What's the reason? Why am I allowed to say that because they're right, they're 90 degrees?
Because the given is that we know that.
No, they already said given. Why can I say they're 90 degrees? What justifies that statement?
Because they said that they were.
Because I said they were. Yes, Garcia.
Is there right angles?
Okay, can I write down because they're right angles? No, what do I gotta write?
Because they have the right angles to
Okay, okay, that's it. I'm glad you're thinking right. But your justification will always be something formal, like a rule, a definition, a property. So why are if it's right, it's 90 degrees. What is that? Is that a theorem, a property, a postulate, a definition? What is it?
The property of right angles or
No, not a property.
definition.
It's a definition, isn't it? The reason this is true is because what? If it's right, then it's 90. That is just applying the definition of right angles. So what am I going to write here? If an angle is right, then it is 90 degrees. Now, what's that?
There's A and B.
Yeah, I put it twice because now I tell you, as we go on, could I have combined, since I combined that here, could I have made this just one statement?
Yeah.
Absolutely. In fact, we should have. I should have done that, but they're trying to do it step by step. So this was really a three-step proof, isn't it? Hey, they're right. Hey, they're 90. And then we'll see that in a minute. Now, later on, maybe not today, but later on, what am I going to let you write in place of if an angle is right, then it's 90? Somebody said it. You said it earlier. No, no, before that, you said definition, right? So technically, what can we say? Definition of what? Of right angle. Put that in like maybe a little parenthesis or something like that. I like if then at first. You know why? Because look at this. If you give me right, then I say they're 90. That's what's happening here, right? But that is a definition of right angle. Now I'm ready for, am I ready to say they're congruent? They're equal, therefore they are congruent. What allows me to justify that? My and.
That they're both right angles?
So I'm going to put here because they're both right angles.
No.
Why am I allowed to say, if they are equal, then they are congruent? Martin, where are you going? Right, it's right here. There's nowhere you're going to go find that. You can't look it up. There's no AI in there. Go right to the cerebral cortex.
If they're both 90 degrees?
Yes, you in the back. Yes, sir. What's your name again? Yeah, JP?
Well, yeah, because they are the both same measurement. Like,
Because they had the same measurement. You're thinking better, but I can't write because they had the same measurement. What would I write instead? I'm going to stick with you because you're thinking right. Is that a definition? Is that a postulate? Is that a theorem? Is that what is that? It's a definition. So it's a definition of what?
congruency.
Good. Definition of congruency, not definition of right angle. If two angles have the same measure, then they are congruent. I could write it. I should probably write it that way, right? If they have the same measure, if they are equal measures, then they are congruent. Which is what? The definition of congruent.
You can put definition of congruency.
Yeah, but for right now, what are we going to write?
If two angles have
If
the
two angles have the same, because that's more clear, right? And we're going to write, if you want, underneath we can write that. I'm with you. I'll write that with you. In parentheses, this is a definition of, and watch what I do. I kind of cheat here. Of congruent what?
congruent angles.
I like if then for right now because if is usually the step above, isn't it? If you give me equal angles, then I can say they are congruent. Because I can reverse that too, couldn't I? I can say what? If the angles are congruent, then they are equal. Because I don't know if you noticed, but definitions go both ways. They do. So that's our first proof. Was that difficult? A little tricky. You'll get the hang of it. The more, it's like anything else. The more you do it, the better you're going to get at it. So this is what I was given. This is what I was to prove. I mean, the only hard part is you had to kind of know what goes in the middle here, right? Remember, I could have, whenever you have two statements that are the same with the same reason, you can always combine them into one. So once again, this could have been a three-step. Okay, we did it. Icebreaker. Golf clap for yourself. How's my time? How are we doing here at Homeland? 12? Can you tell? Don't worry about it.
14 minutes.
Well, that's long. All right, that's okay. But we've explained well. This is the same exact proof, isn't it? Except instead of the word right, what have I replaced it with?
Straight.
It's going to be the same logic, right? If two angles are straight, then they are congruent. I'm probably going to say, if they are straight, then they are
Equal.
If they are straight, then they are
Straight.
180. If they're both 180, then they are congruent. Remember, I'm trying to prove that they are Because they are straight, then they are congruent. How do I prove congruent? I gotta prove they're equal. What if they're 180, they're what?
The same measurement.
We do that again in front of the camera. If I'm given straight and I'm trying to prove congruent, right? How do I prove congruent? I gotta prove that they are equal. What if they're both straight, then they're both what? 180, which is equal. See the logic there? See the sequence? Okay. It's the same exact proof. I'm gonna substitute a few things. Given what? Now what I don't like here is what happened. I don't know what happened to my diagram. Is your diagram on yours?
No.
Oh, we have to do that then really quick. I'm sorry. It should be there. I don't know what happened. Maybe we got to erase. That's not good. Yo, TV reps. What? Oh, when people ask me Mr. Fraser, I go, yo, TV reps. It's a dumb thing I say. You just wanted me to say booby on camera. I'm not going to do it.
You can put number ones and like two together there, right? Do you have to
Hey,
put
let's draw the diagram first. ABC is a straight angle. So what has to be in the middle?
ABC.
What has to be in the middle?
C.
B, thank you. And then A on this side and what? C on that side. DEF is a straight angle. What's got to be in the middle? E, and this should be a D. I don't know why this diagram isn't there. So if they are both straight, then they are both congruent. That's what we're trying to prove. So I have two. Yes, this could have been one statement, absolutely. In fact, 3 and 4 could also be what? And that's how it's going to be later on. But like I said, early on, I want to just go step by step, baby steps. Baby steps. So that's given. Always whichever here goes here. Then that's given. And what's the next statement? We already said it. What is it going to be? Oh, it's not here? So what are we going to write? Angle. Actually, I'm not going to write angle. I'm going to write I'm going to write the measure of angle ABC is equal to 180, and the measure of angle DEF is equal to 180. You're writing the same thing on yours. Not you, Jace. You just sit there and not write anything. You'll be fine. You'll probably get a 62. We can curve that up into a 63. Get in the habit of writing this out. The little things are important. Now, what's the reason? Why am I allowed to say because they're straight that they what is that?
Because the definition of a straight angle is 180 degrees.
The question is, am I going to let you write that for the reason? I probably shouldn't. If two, I use a lot of symbols, right, to make my life and your life easier. If two angles are what?
Straight.
Are straight. I shouldn't say that. That's not right. Sorry.
Why not just one angle?
It's one angle, exactly. Thank you. I was getting ahead of myself. If an angle, I thought this was already typed out. If an angle is straight, comma, then it measures 180 degrees. And I'm only going to write that once. Because why? We could put that in the same thing. Or we could copy and paste it. You'll see sometimes in the answer keys, it'll say C number 3. Why? Well, I don't like to do this, but I've seen it in the textbook. And if you ever look up your answers, it'll say, instead of rewriting the same exact thing twice, it'll say, same as 3, or C number 3, which is the same thing. But we're going to, typically in the future, we're going to make this what? This will just be what? One step. This will just be, so once again, 1, 2, 3 step, or another 5 step. All right. Now, because they have the same measure, it means they are congruent. How am I going to write that? If two angles have the same measure, then they are congruent, which is also definition of congruency. You're not wrong. God, I don't know if I should do this yet. You want to put definition already? It's a little premature. It's not. If two angles have the same measure, then they are congruent. And I think I will put in parentheses, definition of what? Congruent what? Congruent angles. And by the way, this is also what? Definition of what? Definition of straight angle. There's going to be a time, it could be as soon as next week, that I'm going to let you write definition of right angle, definition of straight angle, definition of congruency, and that will definitely come. But right now, I think the if-then is kind of good, because everything is really in the form of what? If this is true, then that's true. Right? But this is about it. I mean, we have some other proofs here, okay? Now, here's the cool thing. Once I prove the theorems, then I can use the theorem.
Okay, good morning, Columbus.
So what does that mean? So next time,
We have 10 cars.
when I give you angle A and angle, when I give you angle C and angle L,
All you
A and C are right, now I can go from right all the way what?
Get you moved, okay?
Straight to the congruent. Why? Because I have a theorem that allows me to do that. That's why we prove theorems, because now this is no longer a three-step proof, it's just a
Dark green Jeep, these are cars
two-step
all
proof.
parked
I can go
along
from
in
right all the way
elementary
to congruent because of the
that
theorem.
are,
Okay?
again, illegally parked.
So
Dark
here we
green
go.
Jeep,
Right angle,
KFC
therefore
are
congruent. Why?
60.
Because if two angles are right, then they are
RQE
congruent, which is a theorem.
299.
I usually write the theorems out in the if-then form. Sometimes I give them names. I might call this the right angle theorem, the vertical angle theorem. We're not ready there for yet, but there will be times when I'll have shortcut names.
M81, Gray Highlander.
That's kinda cool, right?
36
You see the need for theorems now, right?
White Tesla, L, WB.
This is a good time to understand why announcements during the middle of class are
76,
very
and a
annoying.
black RAV4.
But we're gonna fight through it.
EER.
What about here?
Basically, if you're parked alongside.
This is one thing that's kinda weird.
pool,
Diagram is shown. What the heck? That's all they're gonna give me the diagram?
Your car.
Do you remember the things that we're allowed to
Again,
assume?
bring your belongings
Lopez, right?
To the main office.
What was one of the things that I'm allowed to assume from that diagram?
Well, H and J are 180 degrees because they're straight. Or well.
Okay, you said something very nice and something not so nice. I'm going to take the nice part. He said that H and J are a straight angle. So what he's saying is that these points are collinear. Also, since these are collinear, they must form a straight angle. So yes, this is a straight angle. Are we allowed to assume straight angles? Yes, because we're allowed to assume collinearity, right? We're allowed to assume that because they're all on that line that they are collinear. And if they're collinear, then they must form a. So that's one of the other things we're allowed to assume is a straight angle. So, diagram is shown. What do you think I'm going to write here? And Lopez, you kind of had it right. You just said it wrong. You're not going to say HJ. You're going to say what?
HFJ.
HFJ and what?
EFJ.
EFG are straight angles. Okay, here's a little bit of an outlier. What is the reason for that? Why? How did I go from the diagram to saying that the angles were straight?
Because they're collinear points.
Okay, you're not wrong because they're collinear, which means we were allowed to assume it, weren't we? Because they're collinear, we were allowed to assume. So guess what we write for the reason? You think we write that very often? No, very, very, very rare do we write assume from diagram because we're not allowed to assume very much. So this is one of those times that the reason I said they're straight is because assume from diagram. You got that down? Is it on there yet or no? And then of course, because they're both straight, I can go all the way to saying what? What can I say now? Remember, my last statement's going to be what I'm proving. So this is going to be that they are congruent. Is this because of definition or the theorem? Rueda? The theorem. What did the theorem say? If two angles are straight, then they are congruent. You wrote all that down already? Okay, you're fast. Please get these down. Remember, this is not hard, but when you get home and it's Sunday night, 10:30, Sunday night football's on. Martin's eating Cheetos. Not too many Cheetos. Get the crackers. I like the baked ones, actually. And I like kettle corn.
So the first reason's always going to be given.
Yes. You know what the most common error is? What do you think people put for the last reason? Since that's given, what do you think they put here? Prove. Do you ever put prove here?
No.
No, never. But I'll see it like 5 times in the first test. Prove. No. The reasons are always what? Definitions, postulates, theorems, properties. This is kind of, like I said, once again, assume from diagram is very rare. Very rare. Because we're not allowed to assume very much. Here's actually a proof. Am I proving a theorem or anything here? No, I'm just saying, hey, this angle's 50, this angle's 40, and this angle's right. Prove that the angles are congruent. Okay, so that's kind of, this is where we get the word backwards. If angle X is a right angle, if angle X is a right angle, and I want to prove that this angle is congruent to this angle, I bet I have to prove what? That this is also what? Then if I can prove them both right, then I can say that they are congruent because there's that theorem that says if I got 2 right angles. You see how I'm working backwards? That's kind of like the Uno, right? With the 8, I had to work back to the red and then, okay? Is that making sense? Okay, so I haven't written anything down, but that's the plan. So how am I going to prove that this angle is right? Well, I know that 50 and 40 equals what?
90.
Is yours filled out already?
Yeah.
Okay, good. I was going to let you take a picture if not. Because I'm trying to save a little bit of time. So here's a good example of a little multi-stepper. I'm trying to prove the angle's congruent. I'm not proving a theorem or anything. How am I doing that? By proving that they are both right. I'm already given that one is right. I just have to prove that because this is 50 and 40, that would make the angle RSV also equal that. One more time. Given. Now here's kind of a weird one. What got me from here to here? All I did was what? Add. Some textbooks, they call this simplifying. I'm just simplifying, right? There's no property, there's no definition, I'm just adding, right? So I wrote addition. What?
You would say simplify or addition?
Just write addition, because that's what you did. I mean, I think it's easier to describe what you did. It's not the addition property, because that's actually something different. It's just addition. Now, because I have a right angle, what am I allowed to say?
Or is the right?
That it's right. Why? Because if an angle is 90 degrees, then it's right. What do you want to say later? Definition of? Right angle. And wait a minute, they also gave me what? X is a right angle. So now I have what? They're both right angles, therefore they are congruent. Now how am I going to write that? Tell me your name, third guy? Yes, third guy, me.
Gabriel Boston.
Gabriel, talk to me. What am I going to write here? If
If they're both 90 degrees and they're congruent.
they're both 90 degrees, they're congruent. Close. If they're both right, then that's what the theorem says, right? So it's going to go here. If they are both, if 2 angles are right, then they are congruent. Do you guys have this proof? You said you did, right? Did the bottom part? Whatever part you don't have, fill it in. This is a nice proof too. It's in the homework.
For reasons number 6, I put if 2 angles have the same measure and they're congruent.
No, it's not what you proved. You didn't prove that. You understand that? You did it. You only proved that one of them was 90. Because then you'd be proving the theorem, right? Use the theorem. Don't prove the theorem. Once you prove the theorem, you want to use it. Okay.
So take it back.
Now, if they would have given you 90, if they would have said, I see your logic. If they would have said that's 90, right? Then I wouldn't have proved them right. I would have said, oh, that's 90, then that's 90, then they're equal, therefore they're congruent, right? But I said that's already right, so now I just got to prove that's right. It's a similar process. You're not thinking bad. You understand?
Yeah.
Depends what they give you. Now, one more small thing. Remember I say you always put all the given in the beginning? Could I have put step number 5? Could I have put that with all this? Could I have put step 1? Come on, baby. Could I have put step 1, 2, and 5 all together in one statement?
Yes.
You can. Why did they put it down here? Because they didn't want to put the given until you use it. I wasn't going to use this given until when? The very bottom. But a lot of times, because you feel more comfortable, you get that, whatever's given, what do? You just kind of plot all this stuff right into the first one and you call it given. That's okay. That's going to make you feel comfortable for a while. As we get better, sometimes we don't put the given until we're going to use it. I want to give you a little heads up on that.
For reason 3,
Rocco!
would you ever have to specify that you're adding the RSP and TSP?
You're just adding angles together, yeah?
But would you have to like write that
Addition. Keep it
of-
simple. No, just addition.
Alright.
You're adding, simplifying. We.
What if instead of saying that X was right, they gave you X was 90 degrees?
That's what he asked.
Yeah.
If they would have said X is 90, then I would have said this is 90, and then I would have gone what? They're congruent. Why? Because they had the same measure. So it's a slightly different proof. And here's the cool thing about proofs, Ramos. When you went wrong, you could have went that route. It may have been extra steps, because you would have had to say right then 90, then you had 90. Actually, it would have been the same amount of steps. So yeah, it's fine. There's a little bit of flexibility as we go, especially. But you weren't wrong. We good?
Yeah.
Yeah.
We have a chicken
All right, let me see. I think I'm done.
Yeah.
I think I'm done, right?
Yeah.
Oh, we did it. Yay.
What is it?
Hit stop. Thank you.